Welcome back, Focus Learners. Today, we are hitting a massive milestone. It is day 4, and we're looking at Git, pull requests, and the entire code review lifecycle. You know, if you've ever wondered how thousands of developers at a company like Spotify can actually build software together without constantly overwriting each other's work or, well, completely breaking the product, you are absolutely in the right place. This explainer is your ultimate guide to understanding how collaborative code actually gets reviewed, refined, and finally merged. We're going to completely take the mystery out of this workflow. Here's our roadmap for today. First up, Git and pull requests. Then we'll walk through the code review process itself. After that, we await the final verdict. And finally, we'll wrap up with time to practice.
Section 1. Git and pull requests, initiating the code lifecycle. Okay, let's dive into this. First phase of the code's journey, tracking your changes and formally asking for them to be included in the main project. So imagine this scenario. You've been coding away for, 3 hours. You've tweaked a few files, you deleted some old logic and added a shiny new feature. But right before you tap your teammate on the shoulder to show them, you have this sudden moment of panic. Did you accidentally delete a crucial semicolon on line 42? Or maybe did you leave a console log reading "please work" right in the middle of the homepage? It happens. So how do we see exactly what changed in our code before sharing it with the world? We absolutely need a way to verify our own work first.
Well, the answer to that anxiety is a little magic called Git diff. It's a command that shows the precise line-by-line changes made to your files. Honestly, think of it like a high-definition X-ray for your code. It doesn't just tell you that a file was modified, it shows you exactly what was removed, which is usually highlighted in red, and exactly what was added, usually highlighted in green. Seeing what changed is literally the very first step in any review process. It allows you to self-review, clean up your messy, unreviewed modifications, and make sure you're only presenting exactly what you intend to present.
So you've run your Git diff, you've looked at the red and green lines, and the code looks completely pristine. You're incredibly proud of this new feature, but it's still just sitting there on your laptop. This brings us to our next crucial question. Once we've tracked our changes and we know they're good, how do we actually ask the team to merge them into the main project? I mean, we can't just forcefully shove the code into the main database, right? That would be total chaos.
We do it through pull requests. A pull request is exactly what it sounds like, a formal request to merge your newly written code into the main project. Now, what's really interesting about this concept is that a pull request is not just a terminal command or a simple button click. It's actually the initiation of a collaborative conversation. When you open a pull request, or a PR, as you'll definitely hear it called, you're creating a dedicated space where your team can view your Git diff, understand your intent, and discuss the implementation before it ever goes live. It's basically the digital boardroom for your code.
Section 2. The code review process. Collaboration in action.
The pull request has been opened, the invitation has been sent out, and now the gateway to peer feedback is officially unlocked. This is where your code really gets battle-tested. Let's move on and see how this builds into an actual workflow. It's an iterative loop, really. Step 1, as we just discussed, is opening the pull request. Once that happens, the reviewers jump in for step 2, leaving inline comments. And if they see an easy fix, they move right to step 3, offering suggested changes. You see, this isn't a one-way street. It's a dynamic loop where the author and the reviewers interact directly with the code, refining it together step by step until it's absolutely bulletproof.
Let's break down step 2 a bit more. Inline comments are feedback and notes left by reviewers directly on specific lines of code. Now, why does this matter? Well, imagine trying to review code via email. Hey, on line 147 of the user authentication file, I think you used the wrong variable. Yeah, by the time the author reads that, the code might have completely changed, or they might struggle to find exactly what you even mean. Inline comments solve this by anchoring the communication directly to the context. You highlight the exact line, leave your thought, and the author sees your feedback precisely where it applies. It is highly targeted, highly contextual communication, a real game changer. But sometimes a comment just isn't enough. Sometimes the reviewer knows exactly what the fix should be. Maybe it's a simple typo or a much better method name. That is where suggested changes come in. These are specific, actionable code modifications proposed by a reviewer that the author can instantly accept. And honestly, this brilliantly illustrates the power of modern code review tools. Instead of the author reading a comment, going back to their editor, making the change, and re-uploading the whole shebang, the reviewer provides a literal code fix right inside the review interface. The author clicks Commit Suggestion, and boom, the code is updated. It takes collaboration to a whole new level of efficiency.
Section 3. The final verdict.
reaching a consensus. Eventually, that whole loop of comments, suggested changes, and updates comes to an end. We finally arrive at the climax of the code review process. This is the moment of truth where the reviewer has to look at the final state of the code and make a definitive decision. Because reaching a consensus is absolutely vital for the health of the software. The reviewer is essentially facing a fork in the road here. On one side, we have approve. This means the code is confirmed ready, it meets the team's standards, and it's totally safe to merge into the main branch. On the other side, we have request changes. This means the code requires further modifications based on the feedback provided, and it's strictly blocked from merging until those issues are resolved. So the crucial point is that this isn't personal, it's a quality gate. Request changes isn't a rejection of you as a developer. Actually, scratch that. It's more like the system working exactly as intended to ensure only the best, safest code makes it into the final product.
Section 4. Time to practice. Taking action.
All right, we've covered the theory. We've traced the journey from a local Git diff all the way to that final, satisfying, approved decision. But as you know, knowing the theory just isn't enough. It's time to take action and turn this intellectual understanding into actual muscle memory. So here is your core assignment for today. I want you to go to your computer, open up the terminal, make a small change to a project, check your Git diff, push it up, and create a pull request on your very own GitHub repository. Literally go through the motions, look at the interface, leave an inline comment on your own code, suggest a change to yourself. The only way to truly master this workflow is to just do it. I know I feel a little strange reviewing your own code, but it's the absolute best way to familiarize yourself with these tools without the pressure of a live team environment. So here's the final question I'll leave you with today. Are you ready? Are you ready to initiate your first real collaborative code review and master the pull request? The tools are right there waiting for you. Get into your repository, start making changes, and start experiencing the collaborative power of the code review lifecycle. Thank you so much for joining me for this explainer today, focused learners. Now get out there, write some great code, and I'll see you in the next one.